Hello, we are the Tilting Marble Maze team. Our team is made up of 4 biomedical engineers and 1 mechanical engineer. Our goal is to develop a collaborative game that takes user inputs from EMG and converts them into mechanical actuation. In our case, it is a tilting maze in which the users work together to navigate a ball through. This device would be used to help showcase and educate users on EMG while also showing an application of EMG that is not restricted to the medical field. EMG signals are collected using reusable silver chloride electrodes connected to a MyAware EMG sensor, which does some preliminary filtering and processing. After that, the signal is compared to threshold values which are set for each user at the beginning of the program when they are asked to output their maximum possible flex. The thresholds determine the speed at which the game board will rotate. A greater amplitude in the EMG signal will cause the board to move quicker. Users will have signals collected from both their left and their right biceps. The left will rotate the board in a counterclockwise direction and the right in a clockwise direction. If there's an EMG signal being received from both sides, the side outputting the higher amplitude will dictate the board motion. From there, servo motors take instruction from the Arduino and turn the shafts that move the board. Our game board is made of particle board, which holds the maze, which was 3D printed out of PLA plastic. It was split into 4 sections to help make it modular so that the difficulty of the maze can be easily changed. The board is attached to a frame. The frame needed to be able to withstand the stresses put on it by the 18-inch by 18-inch board. For that reason, angle aluminum was chosen for its ability to handle those stresses and it being relatively lightweight itself. This frame is rotated for one axis of rotation directly from one servo motor, and another servo motor attached to that frame turns a shaft which the inner game board is attached to for the second axis of rotation. One of the main challenges of this project was coming up with a design that would be able to meet the demands of Imagine RIT, namely the high user throughput. Nearly every aspect of our design, from the collaborative nature to maze difficulty to the reusable electrodes, was done with this challenge in mind. Thank you, and we hope you enjoyed our Imagine exhibit. We would like to give special thanks to our guide, Sarah Brownell, our customer, Dr. Elizabeth D. Bartolo, and all of the other RIT staff that helped us along the way.